Welcome back. In the last episode, we explored the difference between PFDs and PNIDs, the two most fundamental tools in process engineering. Now, it's time to move deeper into equipment selection and sizing, one of the core responsibilities of a process engineer. But first, if you're new here or haven't watched episode 1 to 3, I highly recommend starting there so you don't miss the key foundations of design engineering. Every industrial plant is made up of carefully selected and sized equipment that may consist of columns, reactors, heat exchangers, pumps, compressors, and separators. As a process engineer, you need to choose the right equipment for the job. This means balancing performance, safety, efficiency, and cost. If the equipment is too small, the process won't work efficiently. If it's oversized, you waste energy, materials, and money. Your goal? Find the right fit. Equipment sizing is based on process conditions and operating parameters. Let's take some common examples. Heat exchangers, where sizing is based on heat duty, temperature difference, and heat transfer coefficients. Pumps and compressors. Selection is based on flow rate, pressure head, and fluid properties. Reactors, where sizing is done based on reaction kinetics, residence time, and conversion rates. Distillation columns design is based on the number of stages, reflux ratio, and separation efficiency. Each piece of equipment requires specific calculations and design rules to ensure it meets process needs while maintaining safety and efficiency. Let's say we need to select a pump to transport liquid from one vessel to another. A process engineer should take into account several key considerations, including the flow rate and pressure head. This involves a clear understanding of material balance, where one should know how much fluid needs to be pumped per hour. What's the pressure required? Considering fluid properties, is it a viscous liquid, slurry, or volatile fluid? This affects the pump type. Choosing the right pump type, for example, centrifugal for low viscosity fluids, positive displacement for high pressure applications. Checking the NPSH, net positive suction head, to avoid cavitation issues, which can damage the pump. This is just one example. Each piece of equipment follows a similar step-by-step approach for selection and sizing. Wrapping up this episode, equipment selection and sizing is a fundamental skill for process engineers. Every design choice impacts efficiency, cost, and safety. In the last and final episode, we'll discuss the process engineer's roadmap. Tell me, which equipment do you find the most challenging to size and select? Drop a comment below.